Now we will see how trigonometric identities appear in integration question. So part 1, example 3, show that sine theta over cosecant theta minus cotangent theta equals to 1 plus cosine theta. So we have tried this kind of question before. Alright, so let's see. Question 1. We will attack from the more challenging side, which is the left hand side. So I will start it from left hand side. Left hand side, I have sine theta over cosecant theta minus cotangent theta. So think a few steps ahead before you change it. Otherwise, you'll be going round and round. Sine, I cannot change. Cosecant and cotangent, I can change. But what do I want to change? Alright, there are different forms I can change. So after thinking through, because there's a sign at the numerator, there may be some cancellation or trigo identity can be formed if I change this to sine theta, and if I change this to cosine theta over sine theta. Okay, because I think a few steps ahead, I foresee that this will work. So I'm dividing by 1 minus cosine theta sine theta. So when sine theta divided by a fraction, it means multiplying by the opposite, right? Sine theta divided by 1 minus cosine over sine, it means multiplying by sine theta over 1 minus cosine theta. Okay, this is what you learn in primary school and in sec 1, sec 2, lower sec. Keep change flip. When you divide by a fraction, means you times the opposite of the fraction. So I get sine square theta over 1 minus cosine theta. Alright, we are getting very close because sine square theta can be written as 1 minus cosine square theta. Okay, if you can recall. If you don't understand why, because sine square theta plus cosine square theta equals to 1. Then bring the cosine square theta over. And for this, 1 minus cosine square theta is 1 minus cosine theta 1 plus cosine theta over 1 minus cosine theta. So cancel away, I'll get 1 plus cosine theta. This is my right hand side, and I've shown. Right hand side shown. Okay, you may have some other method, but please use the correct trigo identity. Okay, part 2, hence find this. If I were to see this question without doing the trigo identity, it's almost impossible. So I have to do that's why there's a part 1 to do the trigo identity. Except the only difference as we compare this and the one at the bottom, the only difference is this number 2. Alright, so don't worry, this number 2 can be brought out. I will bring this 2 out. Okay, so I use the remaining space over here for part 2. Integrate 2 cosecant theta minus cotangent theta dx equals to 2 times of this. Okay, I forgot to write sine theta. So basically I just bring out the 2. Theta minus cotangent theta dx. Oh, hold on, it should not be dx because this is in terms of theta, so it's not dx, it's d theta. D theta, d theta. So now I change the form using the identity from part 1. I will change to this. Oh, when I change it into this form, it's so much easier to integrate, right? Alright, so I just put the 2 outside. Integrate 1, what do I get? Do I get x? No, because it's d theta, I'll get theta. And I integrate cosine theta, what do I get? I get sine theta. So the question is easily done. Then just put plus c. Next question. If you have difficulty in this question, you can pause the video and watch again. Okay, the next question is a new type of question. It's basically understanding It's basically logical lah. If you differentiate, one function, you get the other function. Then the reverse, you integrate that function, you get back the original function but plus c. Okay, let me repeat. You differentiate this, you differentiate green, you get blue. So if you integrate blue, you must get back green. But don't forget, you have an additional plus c to write. Alright, so now I'm going to differentiate the green. Okay, differentiate the green, which is this. Let's see. Differentiate this. Ln x. Clearly it's product rule. Differentiate first term times second term plus differentiate second term, which is ln x. You differentiate ln x, you get 1 over x times first term. Simplify a bit. 4x cubed ln x. Simplify this, you get x cubed. So done for part 1. Part 2, they say hence find x cubed ln x. By right, if part 2 is a standalone question, we are not able to integrate x cubed ln x. We are not able to integrate that because there's no quotient rule for integration. But let's look at the formula above. Since it is the reverse of differentiation, I try to look at my previous question. Can I see any x cubed ln x in my previous question? If you look carefully, it is here. Okay, it appears here. Correct? Alright, so I have to do very slowly. Okay, do very slowly how to get the correct answer. So, but the only difference is there is a 4 there. There's a 4 there. So first thing I must remember that if I do the reverse, if I integrate the whole thing, I should get back x4 ln x. Am I right? Okay, because of the formula I apply above. Okay, so if I integrate this, I should get back x power 4 ln x. Then I must stay focused on what do I want. I want this. So I just stay focused on this. I want to integrate this. The rest, I will shift to the right hand side. So for this, right, I want to break them up first. I break them up into integrate 4x cubed ln x dx plus integrate x cubed dx equals to x4 ln x. Again, stay focused on what I want. I want this. I want to integrate this. Okay, that is what I want in part 2. So stay focused and just keep it here again. Let's evaluate this. What is this? If I integrate this, is x4 1/4 equals to x4 ln x. Okay, I know you're worried about the plus c. Don't worry about plus c. You want to put a plus c here, also can. Okay, you want to put a plus c at the back here, also can. Because eventually, as long as your final answer, you have a plus c, then it's correct already. Okay, I don't have to bother about plus c1, plus c2 or what. It doesn't matter. So now, this is unnecessary to be on the left. I will shift it to the right. So I have, again, 4 integrate equals to x4 ln x minus 1/4 x4 plus c. Hey, I'm almost done. With the question. Except there is an irritating number 4 here. So what should I do with this 4? Yeah, divide both sides by 4. And I am done. Okay, I'm done with this question. Okay, so this is one good method to solve this kind of question, the reverse method. So divide by 4, you get x power 1 quarter x power 4 ln x. Then negative 1 quarter divided by 4 is 1 over 16 x4 plus c. The c don't have to divide by 4, just leave it as plus c. Okay, I will stop here for you to digest. If you need, just stop the video, watch it again. So remember, stay focused. Stay focused on this portion. Am I finding the correct answer? Yes, I'm finding the correct integration of x cubed ln x. And how do I do that? I integrated this so that I can get back the original.